How do Dirac inner products differ from outer products? Imagine you're trying to understand how quantum states relate to each other or how they can be transformed. In quantum mechanics, two key tools help us do this: the inner product and the outer product. They might seem similar because they both involve quantum states, but they serve very different purposes. Let's explore what sets them apart. First, think of the inner product, written as phi psi. It takes two quantum states, called vectors or kets, and gives back a single complex number. This number tells us how much the two states overlap or resemble each other. If the inner product is large in magnitude, the states are quite similar. If it's small, they are quite different. The square of this number, called the magnitude squared, gives us the probability that if the system is in state psi, measuring it will find it in state phi. This is a fundamental idea in quantum mechanics because it connects the math directly to measurement outcomes. Mathematically, the inner product is similar to the dot product in regular vectors but extended to complex numbers and infinite dimensional spaces called Hilbert spaces. It is linear in one argument and conjugate linear in the other, which helps keep the math consistent and meaningful. Now let's look at the outer product, written as psi phi. This is quite different because it combines a ket and a bra to produce an operator, which is like a matrix that acts on quantum states. Instead of giving a single number, the outer product creates a tool that can change or project states. For example, the outer product 0, 0 is a projector that filters out everything except the state 0. These operators are used to describe measurements, prepare states, or representing how a quantum system collapses during observation. Unlike the inner product, which measures similarity, the outer product constructs operators that manipulate states or extract information from them. These operators are not necessarily unitary, meaning they don't always preserve the size or norm of states, but they are essential for describing the processes in quantum mechanics. To sum it up, the inner product is like a ruler that measures how close two states are, giving a number that relates to the likelihood of transitioning from one state to another. The outer product, on the other hand, is like a machine that can project, transform, or measure states, creating operators that do specific tasks in quantum systems. Understanding both helps us grasp how quantum states relate to each other and how we can control and measure them in quantum technology. Whether you're working on quantum computing, quantum communication, or just trying to understand the basics, knowing the difference between these two products is fundamental to mastering quantum mechanics.